Hi everyone, I'm Rinil Delino from the Mathematics Department, and today I will discuss with you the antiderivative and the power formula. So for this lesson, we will cover the following topics. First, we will discuss the definition of antiderivative. Next, we have the properties of indefinite integrals, or called as the basic integration formulas. Next, we have the integration using power formula. And the last is the integration using U substitution. So before we start, now let me discuss with you the objectives of the study. So at the end of the lesson, the student must be able to define anti-differentiation or integration. Be familiar with the properties of indefinite integrals. Perform basic integration by applying the power formula. And perform integration using simple substitution of antiderivative. Let me start by defining what an antiderivative is. So by definition, a function big F is called an antiderivative or integral of the function small f on a given interval if the first derivative of the function big F of x equals the function small f of x for every value of x in the interval. Like for example, the function big F of x equals 1/4 x to the fourth is said to be an antiderivative of the function small f of x equals x cubed on the interval negative infinity to positive infinity, since for each x in the given interval, the first derivative of the function big F of x equals the derivative of 1/4 x to the fourth with respect to x, which is equal to x cubed. And this function is also the same as the function small f of x. However, the function big F of x, which is equal to 1/4 x to the fourth, is not the only antiderivative of the function small f on the given interval. Because if we add any constant c to 1/4 x to the fourth, the function denoted by g prime of x equals the derivative of 1/4 x to the fourth plus c with respect to x equals x cubed, which is also the same as small f of x. So in general, once any single antiderivative is known, the other antiderivatives can be obtained by adding constants to the known derivatives. Thus, this function 1/4 x to the fourth, 1/4 x to the fourth plus 3, 1/4 x to the fourth plus 5, and so on and so forth, all of these are antiderivatives of the function small f of x equals x cubed. So in general, according to this theorem, if the function big F of x is an antiderivative of the function small f of x on an open interval, then for any constant c, the function big F of x plus c is also an antiderivative on that interval. So moreover, each antiderivative of the function small f of x on the interval can be expressed in the form of big F of x plus c by choosing the constant c appropriately. The process of finding antiderivatives is called antidifferentiation or integration. Thus, the derivative of big F of x with respect to x equals small f of x. Then integrating or antidifferentiating the function f of x produces an antiderivative of the form big F of x plus the constant c. So to emphasize this process, we use the following notation. The integral of small f of x dx equals the function big F of x plus the constant c, where the quantities on the left side, the integral of f of x dx is called the antiderivative. This symbol is called the integral sign. F of x is the integrand, c is the constant of integration, and dx indicates that x is the variable of integration. Some of the properties of indefinite integral and basic integration formulas are listed below. So these properties need no proof from the fact that these properties are also known properties of differentiation. The first formula is the integral of dx equals x plus c. So this is obtained from the definition of indefinite integral. Then number 2 is the integral of the product of the constant c and the function f of x times dx. Because c is constant, so we factor this out. So we have c times the integral of f of x dx. But from the definition of the definite integral, the integral of f of x dx is f of x, big F of x, plus the constant c, times the constant c, so you have c times the function big F of x plus the constant c. Okay, the third formula is the integral of the sum or difference of n functions with respect to x. So this is equal to the sum or difference of the integral of each function. So given the n functions, f sub 1 up to f sub n, and then the integral of the sum or difference of these n functions is obtained by applying the distributive property. You distribute the integral sign together with dx to each of the term. So therefore, the integral of f sub 1 of x plus or minus f sub 2 of x plus or minus and so on and so forth plus or minus f sub n of x dx is equal to the integral of f sub 1 of x dx plus or minus the integral of f sub 2 of x dx plus or minus and so on and so forth plus or minus the integral of f sub n of x dx. Okay, the fourth formula is called the power formula. And the power formula is of the form integral of x to the n dx. And this is equal to x to the n plus 1 over n plus 1 plus the constant c, provided that the value of n is not equal to negative 1. So you can easily apply this by increasing the exponent by 1. So you have x raised to n plus 1 divided by n plus 1 plus the constant c. The last topic for this lesson is the U substitution. This is also called the general power formula. In evaluating the integral of f of g of x times g prime of x dx, it will be more convenient to let u be g of x and write the differential form du equals g prime of x dx. So this integral by substitution can now be written as f of g of x, where g of x is u, so you have f of u times g prime of x dx, which is du. So we have the integral of f of u du equals the function big F of u plus the constant c. So from this equation, we can generalize the power formula as follows. We have the integral of quantity f of u, quantity raised to the n power, times the differential of the function f of u. And this is equal to the function, which is f of u, quantity, close quantity raised to the n plus 1 over n plus 1 plus the constant c, provided that n is not equal to negative 1. Or, if we let f of u as u, you have u to the n and the differential of f of u as du. So we have u to the n plus 1 over n plus 1 plus the constant c, provided that n is not equal to negative 1. The method of U substitution may be applied in evaluating an integral with the substitution u equals g of x and du equals g prime of x dx. Suppose we are asked to evaluate the integral of 6x squared minus 4x plus 5 dx, because this integrand contains 3 terms. So you can apply formula number 3, which states that the integral of the sum or difference of n functions is equal to the integral of the first function times dx plus or minus the integral of the second function f sub 2 of x dx, and so on and so forth, up to plus the integral of the last function, which is f sub n of x dx. Or you can apply distributive property. You distribute the integral sign together with dx. So applying that formula, we can now rewrite this as the integral of 6x squared dx minus the integral of 4x dx plus 5 or integral of 5 dx. Because this product contains constant and a function. So applying formula number 2, which states that the integral of constant and the function dx is c times the integral of f of x dx. So you factor out the constant, which is 6, times the integral of x squared dx. So you do the same for the rest of the terms. You factor out the constant 4 times the integral of x dx plus 5 times the integral of dx. And because this x squared dx is of the form formula number 4, which is the power formula, so to evaluate this, you increase the exponent by 1 over the exponent plus 1. Okay, so you have x raised to 2. You increase this by 1. So you have 2 plus 1 over 2 plus 1. Minus 4 times the integral of x dx is x squared over 2. Okay, plus 5 times the integral of dx is x plus the constant c. Then simplifying this further, you have 6 times, you have x to the third power over 3. Okay, minus 4 divided by 2 is 2 times x squared plus the constant c. Or 6 divided by 3 is 2. So we have 2x cubed minus 2x squared plus the constant c. So this is the final answer. Okay, another example. Suppose we are asked to evaluate the integral of 4 square root of t plus 2 over square root of t dt. Because the integrand is sum of two functions, so we can break this into two integrals. So we have the integral of square root of t dt plus the integral of 2 over square root of t dt. And because the first term is product of constant and a function, so you can apply formula number 2, wherein you can factor out the constant. 4 times the integral of square root of t dt plus, same with the second term, you factor out the constant. So we have 2 times the integral of dt over square root of t. Okay, because this is radicals and there's no formula for radical function, so what we have to do is rewrite square root of t as t raised to 1/2. So we write this in fractional exponent form plus 2 times the integral of dt over, so same with square root of t, we can write this as t raised to 1/2. And then to integrate t raised to 1/2 dt, we can now apply formula number 4, which is the power formula. You increase the exponent by 1, so you have 4 times t raised to 1/2 plus 1 over 1/2 plus 1 plus 2 times the integral of, okay, if you look at the integrand, there's no appropriate formula for this. So what we have to do is we write this in power formula form. You place this denominator in the numerator and then you change the sign from positive to negative 1/2. Then simplifying further, you have 4 times 1/2 plus 1 is 3/2. So you have t raised to 3 over 2 all over 3 over 2. Okay, plus 2 times. So this is now of the form x to the n dx. So we can now integrate this by increasing the exponent by 1. So t raised to negative 1/2 plus 1 over negative 1/2 plus 1. Okay, plus the constant c. So simplifying further, 4 divided by 3/2 can be written as 4 times 2/3. You change division to multiplication and then get the reciprocal of the denominator. Times t raised to 3 over 2 plus 2 times t raised to negative 1/2 plus 1 is 1/2. So we have t raised to 1/2 over 1/2 or 1 over 2 plus the constant c. So simplifying further, so 4 times 2 is 8. So we have 8 over 3 t raised to 3 over 2 plus 2 times, you change this to division, to multiplication, tapos get the reciprocal. So you have 2 times 2 over 1 times t raised to 1 half plus the constancy. Or this can be written as 8 over 3 t raised to 3 over 2 plus 4 times t raised to 1 half plus the constancy. So this is the final answer. So in summary, we have learned that the indefinite integral of a function is not unique as it includes the constant of integration denoted by c, which can be an arbitrary number. Okay, you also learn how to apply the basic formulas and the U substitution. Many times now we have to rewrite the integrand to match it in standard form.